Hello again. This is Mark Summers from Summers Technical Services. We're going to do some hand calculations to compute cable forces on the little picture you see on the screen here shortly. It's a traffic light that's hanging from three cables going to three poles at an intersection. And we're going to use techniques, vector techniques to calculate the forces in these cables, and then we'll follow this up with a Solarworks simulation to do the same thing and get different perspective on doing it both ways. So let's get started. So we'll look at the Solarworks model first. You can see it's the same picture. We got this traffic light hanging from these three cables. So there's the three cables. Two of the cables are horizontal. There's no delta Z. And there's one cable, AC, going toward the back that'll have to take all the Z component of the weight hanging here. And so let's think about how we're going to calculate this using our traditional hand calculations. And so first thing I need to do is figure out the geometry here and the length of these three cables. And so I've got the equation here. This is this Pythagorean theorem. So for AB, we're going from the middle of the intersection right above the traffic light over this point B, and the X, Y, Z components to get to the top of this post here is 3, 4, and 2. So we take the sum of the squares equals 25. So AB, the length of the cable AB, is going to be 5 meters. If I can get my screen working here. Whoops, my pencil's coming apart. Now we're cooking with fire. Okay, so this is going to be 5 meters. Square root of 5. Square root of 25 is 5. And then a C is a cable going toward the back there. It's got a Z component. So it's moving over 3 in X, 6 in Y, and 2 in Z. So we take the sum of the squares is 49, so we know the length of AC is going to be 7 meters. And do a similar thing for AD, and that's also going to be 5 meters. So what we're going to do now is take, we're going to create unit vectors along AB, AC, and AD so we can determine what part of that load is going to go in each one of those directions. And so we use these values here. For instance, for the AB unit vector we're going to define, it's going to be 3/5, that's the X component, 4/5 in the Y component, and then no change in the Z direction. If you do the sum of the squares of those fractions, they'll add up to 1, which is why it's a unit vector. So we'll do the same thing over here for AC. We know these are going to be sevenths, and so the X direction on AC is -6, Y direction is -3, and then the Z direction, this is the one that goes up in Z from 4 meters to 6 meters. And so that's the unit vector for AC, and then we'll do a similar thing for AD. The distance is 5, so we've got the fraction is going to be fifths, and then X is 4, Y is -3, Z is 0. That's another horizontal cable, no Z change. And so those are the three unit vectors that define the direction of those three cables. And we'll flip to the next page, and there's the same picture, and there's the same set of unit vectors. I just rewrote them on this page here. So now what do we want to do? Well, we want to sum the forces in the X, Y, and Z directions, because we know, number one, nothing is moving. And so based on our Newtonian equations, we know the forces are going to sum to 0 in the X direction and the Y direction, because there's no external forces in X and Y direction. But in the Z direction, there is a net force, and that's going to be the weight of this traffic light. And in my case, it's the mass is 15 kilograms, and we'll multiply mass times acceleration of gravity. It's going to be a negative value because the weight of the traffic light's going down, which means the cables are going to have to withstand that with a vertical reaction force. And so some of the x, some of the y forces are 0, and then some of the z forces are going to have to equal this to counteract that weight. And so these are the three equations we're going to use to solve I got three equations, I got three unknowns, and so I should be able to solve these. So it's going to be a little bit tricky to do it with algebra. I have to do a lot of manipulation, take a lot of time. So I'm going to use a matrix multiplication to solve this problem. So there's the three equations again from the previous page. Three equations, three unknowns. I'm just going to convert this into matrix form. And so look at this first equation. We're going to multiply these first row by the column here. And so we'll go through one at a time and see where these show up in the equation. So looking at this equation right here, I've got 3/5 times FAB. And I got minus 6/7 times FAC. And I got plus 4/5 times FAD. So I can continue that with the other two equations, put those in the second row, and then this last equation will go in the third row. And so this matrix multiplication here will give me the answer down here on the right. And so these values here are just, let me a different color here. So there's a 0, there's a 0. There's a 147.15 that represents the weight of the traffic light. And so what I want to do is take advantage of my HP prime calculator, and I've built this matrix and I've called it M1. So this 3x3 matrix here is M1, and I call this matrix over here, I've defined it as M2 in my calculator. And to solve for FAB, I just need to take the inverse of M1. I multiply the left side of the equation by the inverse of M1. Well, the inverse of M1 times M1 is going to be the identity matrix. And so I'm just left with FAB, FAC, FAD in a vertical matrix. And then multiply on the right-hand side, I'll multiply the inverse matrix by M2, and that'll solve for FAB, FAC, and FAD. So let's go to my calculator over here and go to, see if I can find my matrix I defined earlier. So there's M1. So this matrix here is this matrix here, 3/5 minus 6/7, 4/5. You can see the rest of the numbers. So what I want to do is invert this, and so I'm going to hit enter to get it on the stack again. I'll say 1, enter, I'll swap them. So 1 divided by this guy, this will give me the inverse of M1. And if I multiply these two together, that's M1 times the inverse of M1. So if I multiply those together, sure enough, I get the identity matrix. 1 on the diagonals, and 0s everywhere else. So that's going to leave me with FAB, FAC, FAD, this matrix right here. So now that we know that that's working, I'm going to go back and get M2 again, or M1, excuse me. There's M1, 1, enter, swap them, divide. So there's there's the inverse of M1. And now I'm going to go get the M2 matrix. So I'm going to call it, say, M2, enter. So there's M2. If I multiply these together, that's going to give me my answers to the three unknowns. So I got 441, and I got 515 newtons, and I got 221 newtons. So that's what I'm looking for, and that's what I got there. So anytime you get more than two equations and two unknowns, once you get into these three-dimensional problems, doing this matrix manipulation, to me, is the easiest way to do it. So now that we think we've got the solution for the forces in these cables using our traditional hand calculations with this vector analysis, let's go take a look at Solarworks, and we'll do a simulation in Solarworks and see if we don't get the same answers. So stay tuned for that video, and until then, enjoy your day, and we'll see you in the next video.